Welcome to the Manana Ventures YouTube channel. Please like and subscribe. This is your tutor figure store. So today we'll be doing trigonometry, proving identities. Okay, now this is a very simple one, but I just want to let you know of my trick on how to prove identities. This is it. Watch this. It's just a statement. To prove identities, you have to simplify everything to cos and sine. That's it. That's how I prove every identity. Just simplify everything to cos and sine. So here we can see that there's a 10 here. So immediately I have to deal with that first. So we will have cos squared x plus sine x times cos x times. Now 10 is actually sine x over cos x. Okay, now there's an acronym that I normally use. It's SO, CA, TOA. Okay, sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and then tan is opposite over adjacent. So now the reason I know that tan is equal to sine over cos is because opposite has to do with sine. So there we go. And then adjacent has to do with cos. So that's how we do that. Now, going back to the question. Now that I have this situation, I can cancel that with that. Cos cancels each other. And then I'm left with cos squared x plus sine x times sine x is sine squared x. Now this is a special identity which is actually equal to 1. Okay, which completes this. The right hand side is now equal to the left hand side. Remember, in our question we're given that this whole thing is equal to 1, so there we have it. Now let's look at a second more complicated one where we have 1 minus 10 squared theta divided by 1 plus 10 squared theta is equal to 2 cos squared theta minus 1. It looks complicated, but let's break it down. Going back to our simple rule, simplify everything to cos and sine. All right, so there we have a 10 there. We're going to do this. 1 minus a 10 is sine squared theta over cos squared theta. This whole thing is divided by that one, which is 1 plus sine squared theta divided by cos squared theta. Okay, we're looking at the left hand side only. All right, now this looks a bit messy, so what I'm gonna do is that I'm gonna separate it into 1 minus sine squared theta over cos squared theta. And then I'm gonna, instead of putting this line, I'll just put a division sign there, and then put this one, 1 plus sine squared theta over cos squared theta. Okay, now we have a fraction. I have a way of doing fractions. I have a trick of adding fractions. Say, for example, I have a over b, say, plus c over d. Okay, how I do this is that I take the denominator as these two. Okay, so I say b d. Once I've written the denominator, I take it and I put it right here next to the BD, next to this, and then next to this one too, BD. Okay, from there what I do is just I cancel. So with the first term, I cancel B, cancels B, and then I'm left with D and A. So I write DA there. I write the sign as it is. And then this D cancels that D, and I'm left with C and B. CB. I can do the same with numbers, just to show you it works with numbers too. 2 over 3 plus 4 over 5. How would I add that? I would take these two as my denominator, which is 3 times 5. Okay, that was the times there too. And then I take that 3 times 5, I'll put it right there in brackets. 3 times 5. I'll put it there as well. 3 times 5. Okay, now this 3 cancels that 3. I'm left with a 5 times 2. I write it there. I write that plus sign there. That 5 cancels that 5, and I'm left with a 4 times 3. Okay, and then that would then be 5 times 2 is 10, plus 4 times 3 is 12, divided by 3 times 5, which is 15. Okay, just to complete this, this would then be 10 plus 12 is 22 over 15. Okay, so we're going to take this very same concept and bring it over here. All right, here we have 1 is just 1 over 1. It's the same thing, just to make it a fraction as well. So likewise, for this one, I would take 1 times cos squared theta as my denominator. We're looking at there. And then I put it there as well. 1 times cos squared theta, 1 times cos squared theta. Okay, just small there. Right, and then I'd say this one cancels that one. I'm left with cos squared theta. Yeah, I put the minus sign as it is. That cos squared theta cancels that one, so I'm left with sine squared theta. Have a division sign there. Do the same. That's my denominator, the 1 times cos squared theta. Take that denominator, put it there. Put it this side as well. Anyway, that one cancels that one, and I'm left with cos squared theta. Take that plus sign as it is. That cos squared theta cancels that one, and I'm left with a sine squared theta. Cool. Next thing is, I come to this term here. I write it as it is. Cos squared theta minus sine squared theta divided by, now I'm cos squared theta, because it's just 1 times cos. Now I want to change this division sign into a multiplication sign. And when I do that, then the denominator becomes numerator and numerator becomes denominator. So the cos squared theta goes on top now, divided by that one, plus sine squared theta. From there, I can see that that cancels that. This is a special identity. Cos squared theta plus sine squared theta is also equal to 1. Okay, so that's equal to 1, such that now I'll be left with just cos squared theta minus sine squared theta. Okay, now I cannot simplify this any further, so I will now go to my right hand side, that one there. My right hand side, let's just put a line there just to show that we're separating. My right hand side, I have 2 cos squared theta minus 1. Okay, I'm going to rewrite that as 2 cos squared theta minus. Now 1 can be rewritten as that, just what we did there. It's a nice special identity, cos squared theta plus sine squared theta. From there, all right, 2 cos squared theta. Get rid of the brackets by saying this negative sign times cos is cos squared theta. That negative times sine is also negative sine squared theta. Okay, from there I have 2 cos squared theta minus cos squared theta. Because these are the same term, I can just subtract them, and I'll be left with cos squared theta, then that one, minus sine squared theta. 2 minus 1 is 1. Then can you see left hand side is equal to the right hand side? Therefore, you can conclude that the left hand side is equal to the right hand side. Therefore, it has been proved. Thank you very much.